4 exponent law is 1. So if we were to do this question, we know that the exponents mean that we have that many of our base. So I could expand this as repeated multiplication. So that means I've got 5 times 5 times 5, multiplying by 4 more 5s. 5 times 5 times 5 times 5. Now, if I counted all my 5s, how many 5s do I have now? I have 7 5s. So my answer would be 5 exponent 7. Okay? Now, can you find a shortcut? You think of something that might be easy so I don't have to write it all out and count the number of 5s? What do you think, Berkeley? Yeah, you're right. You count the top numbers. So the rule is, as long as your base is the same, you take the exponents and you can add them. That's our shortcut. So on the next one, what's it going to look like, do you think? Our base is -4. And what am I going to do? It's going to be exponent 5. Good. I'm going to take my 2 and my 3 and I'm going to add them. Okay, so now this is talking about our exponent laws. For you to write down our shortcut, here's the shortcut for you to write down. So this is our exponent law for product of powers. It says to multiply powers with the same base, and that's again our key words there. Same base. If we've got our same base, all we have to do is add our exponents. So we can see they've used the letter A, same base, they took M plus N. Okay, so that applies to any same base. Please follow along and write that down in your notes. Okay, continuing on to the next rule. So if we have a dividing law, our division law, what do you think we're going to do? Last time we were multiplying, same base we added. Now we have the opposite function going on. Now we're dividing. What do you think we're going to do to those exponents? Subtract them. You are exactly right. We're going to subtract them. So we keep our base the same. It's going to be an 8. Now we take 6 and 4 and we subtract them, so it's going to become a 2. Same thing over here. We've got a -6 as our base. And now we take our exponents, 7 and 5, and subtract them, and I'm going to get a 2 again. Okay? So as long as our base is the same, we subtract when we're dividing. We subtract our exponents. So let's write down the law that it talks about. This is called exponent law for a quotient of powers. Okay, quotient of powers. Quotient means you're dividing. Now you might also see it written as a fraction because the fraction line means divide. So you might see, for example, 7 to the 11 divided by 7 exponent 3. While our base is a 7, now we subtract 11, subtract 3, we're going to get 8. Okay? Now it's telling us here that M and N, these numbers here, they're saying that M has to be a bigger number or the same number as N. That's all they're saying with this. That's all this means, is that M has to be bigger than or the same number as N. So that means that this 11 has to be bigger than the 3 or the same number as a 3. Okay, that's all that's telling us. Did you have a question, Berkeley? If the M is bigger, then we get into grade 10. That's grade 10 stuff. Then we get into negative exponents. They do exist, but we don't deal with it this year. Good question. Okay, so write this down in your notes. Okay, continuing on, we're going to do a couple examples. So, again, remember that it's opposite functions. As long as our base is the same, we can use the rules. But again, we must be multiplying or dividing to use the rules. The rules don't work if we're adding or subtracting. So, multiplying, excellent. Now I can add the exponents because my base is the same. I'm going to get 6 exponent 9. That is considered to be simplified in exponential form, meaning I have it still with an exponent showing. Now, if I wanted the answer, I would say evaluate or simplify completely. If it says simplify completely, it means now take the answer. So you would go 6 exponent 9 equals. Okay, it's a very big number, yes. Okay, on B, we're dividing. So now we're going to take those exponents and we're going to subtract them. So our base is still in brackets, -9, and now my exponent becomes a 4. You guys try the two on the bottom, letters C and D. Push pause now, push play when you're ready to see the answers. Okay, now we're going to take these up. You notice you have the same base. So what do I get when I add my exponents? Hands up. What am I going to get? Desiree? 19, good. Negative 2 is my base, so it has to stay in brackets, and the 19 goes outside. That will give us a very large number if we tried to evaluate. Now we're dividing. So really, I could rewrite it like this. 7 to the 6 on top of 7 to the 3. Same thing. Opposite function, so I'm going to subtract my exponents. I will get 7 exponent 3. Okay, let's move on to the next section. This section tells us now we have to evaluate. Evaluate means actually simplify to a power, then solve the power. So simplifying the power, we have to take a look and see what function we're doing. We're doing multiply, same base. I get to add my exponents. I'm going to get negative 4 exponent 7. Now in my calculator, I type in negative 4 exponent 7. And what am I going to get for an answer? Hands up.
Wait, that's my calculator, bro.
Negative 1,663.84.
Like that?
What? 16,000.
16,000, yes, there we go. So 16,384. And it's a negative number. How can we know it's a negative number? We have an odd number of negative signs. So we have a negative answer. Now we're going to move on and do letter B. If we take a look at B, we've got a couple different functions going on. So it's bedmass. I notice multiplying and dividing go together, but they go left to right. So what I'm going to do is I take the first two and I add their exponents. So now I'm going to get 3 exponent 6. Then I write the rest of the equation beside, divided by 3 exponent 3. Now I can simplify the next set. With dividing, I'm going to take those exponents and now I subtract. So that's going to give me 3 exponent 3, and that's what I type in my calculator, 3 exponent 3, or 3 times 3 times 3, and that will give me what, Dana? 27, excellent. That gives me a 27 for an answer. You guys try C and D, push pause now and play when you're ready for the answers. Okay, moving on, let's take a look and see how you did. Dividing means I'm going to take my exponents. Oh my goodness, let's try again. Means I take my exponents here and I subtract them. So my base is 6, exponent 2. Evaluate says solve it. So that's 6 times 6, which will give me 36 as an answer. Let's take a look at letter D. We have a 2-step process in D. I've got to take the first 2 and solve it, and then write down my second part of my answer, or my second part of my question. So times 5 squared is going to come straight down, and I'm going to solve the first part. The first part's dividing, so I'm going to take my exponents and subtract them, which means I'm going to get 5 exponent 6. Now I have a multiplying function, so I'm going to take the 6 and the 2, and now I add them, because that's my law for adding when I multiply with the same base. So I get 5 exponent 8. Now in your calculators, you take 5 exponent 8, and it's a really big number. What do we get for an answer? Quinn? Is that confirmed by everybody?
Yeah.
Excellent. Good work, everybody. 390,625. Let's move to the next page, please. Okay, here we go. Example 3. Now we see that we've got other functions. We don't always have just our dividing and multiplying. Now we see a plus sign in there. We cannot use our exponent laws when we have a plus sign. That means the 6 squared has to be solved by itself first. So that gives me 6 times 6, which is going to give me 36. And I'm going to add it to what I combine when I do this last part of my question. The last part of my question, they are multiplying, so yes, I can use my rules, and I can add my exponents because I have the same base. So that's going to give me 6 exponent 5. Now I have to solve the 6 exponent 5. So I have 36 plus whatever 6 exponent 5 gives us. Good, excellent. So 6 exponent 5 gives us 7,776. Now I add it to my 6 squared, which is 36. My grand total is going to be
7,812.
Oh, yeah.
7,812. Excellent. Good work, you guys. Okay, let's take a look at letter B. Let's take a look at letter B. Letter B has quite a few things going on. So I've got brackets for bed mass. Inside my brackets I must do first. But then I've got something attached to the bracket. If it's attached, it means multiply. So now I've got to solve inside my bracket, and my negative 10 exponent 4 is still out front attached to it. So I'm going to solve inside my bracket. Since I'm dividing, I'm going to subtract my exponents. So that answer is going to come down now. And again, he's attached to the one out front, so I'm going to times it to the one out front. Times by negative 10 is my base, exponent 2. The rest of my equation gets written down beside minus 10 exponent 7. We just write it down right beside it. And now I've got to work left to right again. I take a look and I try to find if I've got multiplying or dividing. If I've got multiplying or dividing, I can use my rules. Do I have multiplying or dividing? Yes, I do. Right at the front here. Side by side means multiply. I have the same base. I'm going to add their exponents. So this is going to give me negative 10 exponent 6. And then the rest of my equation, again, I write right next to it, side by side. Subtract 10 exponent 7. Now, my base is the same, negative 10. Am I able to add those exponents? No. Good work. How come? Good, because first of all, this is subtracting. Subtracting and adding, I cannot use my rules. Only multiplying and dividing, I can use the rules. That means you have no choice but to solve them each separately and then subtract their answers. So now, remember our exponent tells us how many zeros we have. An even number and a negative sign means I'm going to have a positive answer. I'm going to have 1 million, so 1 with 6 zeros. Subtracting 10 exponent 7, which means I'm going to have 7 zeros. So 1, 10 million.
You're going to have 0.
Now I take 1 million, subtract 10 million. What am I going to get for an answer?
9 million?
Negative 9 million. Good job. So I get negative 9 million as an answer, my final answer. Okay? Let's move on to the last questions. 2 last questions. Give those a try for yourself. Push pause now and push play when you're ready for the answers. Okay, let's take these up together. If you're not finished, let's just take them up together and follow along. So everybody take a look. You've got 4 cubed. 4 cubed becomes 64. Why did I solve it? Because he has a plus sign adding to the rest of them, which means I cannot use my rules to add that in. So I solved by 4 cubed. Now I'm going to take everything else. This means multiply. I'm going to solve inside my brackets, and I'm going to get 4 to the 1, because 12 subtract 11 is 1. And then I times by my 4 cubed on the end. Now I can add my exponents here, and I'm going to get 4 exponent 6. So I have 64 plus 4 exponent 6. Stay put. This is going to give me 64 plus 4096, which is going to give me 4,160. Okay, let's take our last question up here now. You're going to notice that we have a couple different bases, and we have negative exponents. That's okay. We still deal with it the same way. We just add exponents with our same base because we're multiplying. So my hint for you would be to write it down in order, matching everything together that matches. So I'm going to write all my 2's together. So I'm going to bring this one down, 2 squared, and I'm going to write those ones right beside it. Times 2 to the 4th, times 2 to the negative 3. Then I'm going to write down the 3's. So these are the same base of 3, so I'm going to write them beside it. Times 3 exponent 6, times 3 exponent negative 5. Now I can deal with my exponents that have a base 2. I am multiplying so I can add my exponents. So this is going to give me 2 to the exponent 3. Then I'm going to do the exact same thing with my base 3. I'm multiplying so I can add their exponents. So that's going to give me 3 exponent 1. And again, I am multiplying, so now I need to solve each separately. They are different bases, so I cannot combine them by adding their exponents. So solving 2 exponent 3, that's 2 times 2 times 2, which is going to give me 8. I solved 3 exponent 1, which is just 3, and it's asking me to multiply those numbers. So my final answer, evaluated and solved, would be 24. That concludes Lesson 1-4 for Exponent Laws, Part 1. The textbook homework you can work on has been revealed. You can work on your textbook homework to give you extra practice.